Hello everyone, my name is Dr. Roshan Kumar. I am Assistant Professor in the Department of Electronics and Communication Engineering, SR University, Warangal, Telangana, India. So, in previous lecture, we have completed a special diode, that is varactor diode, tunnel diode, LED, photodiode, laser, pin diode, and avalanche photodiode. So today I will discuss you PNP diode, TRIAC and DIACs. So these are the also part of special diodes. So let us come to the that PNP diodes. It is a combination of P-type, N-type, P-type and N-type. Is a four-layer device and also known as a Schottky diode. The function of diode is similar to the normal diode, exclusive for any trigger inputs. These diode include simply two conditions like is either on and off. So these diodes are classified as a thyristors. So, construction of PNP diode is also known as a circuit diode. A PNP diode is formed by sandwiching four semiconductor layers. The layer sequence is P-type semiconductor material, N-type semiconductor material, again P-type and N-type semiconductor material. Because of this arrangement, three junctions are created, that is junction 1, junction 2 and junction 3 reflected in the picture. So the junction 1 created between the first P-type semiconductor and N-type semiconductor layer, and junction 2 created between N layer to P layer, means N-type semiconductor layer and P-type semiconductor layer. Junction 3 created between P-type and N-type layer. So overall, we have a four-layer, three-junction device. We can say like that PNP diode is a two terminals, four-layer and three-junction device. Now, looking at the terminals, the anode is connected to the outer P layers, means anode is connected to the outer P-type semiconductor layer, and the cathode is connected to the outer N-type layer. So, biasing conditions: when the PNP diode is operate in forward bias condition, junction J1 and J3 are forward bias, and junction 2 is reverse bias. This reverse bias junction 2 is initially block the current flow, keeping the device is off states. So key idea, so even though the diode is forward bias, that is extremely, the middle junction control the conduction, which make the device we have different form of normal PN diode. So when this diode is operated forward bias, the both junction like J1 and J3 are forward bias and J2 are reverse bias. Next, we understanding the equivalent circuit of PNP diode, also known as Shockley diode, using two transition models, two transistor models. So basic idea, the PNP structure can be represented as two interconnected transistors, which is clearly reflected in that picture. One PNP transistor T1 and other is NPN transistor T2. These transistors are connected to in a such way that is the collector of one transistor is connected to the base of the other transistor. So that this creation is a feedback loop inside the device. So junction corresponds that emitter base junction of the transistor 1 is from the junction 1. The common connection between terminal 1 and terminal 2, that is form a junction 2, and the emitter base junction for transistor 2 from junction 3. So regenerative feedback mechanism behind this PNP circuit, this configuration result the positive feedback when a small current start flowing in that one transistor. It's active the other transistor. This is turn increase the current in the first transistor. This cycle continuous repeat leading to the larger current flow. So key understanding for that structure, initially the device is off state. Once trigger, both transistors on simultaneously, this device enter a conducting on state. So important model, these two transistors help us to understand switching behavior of PNP diode. So, next is working. A PNP diode operated based on the junction bias and regenerative feedback, which give in switching characteristics rather than simple diode behavior. So let us consider a forward bias connection. The anode is positive and cathode is negative. Junction J1 and J3 is forward bias. J2 is reverse bias. Because of J2 is reverse bias, it blocks the current flow. So only a small leakage current flow, the device is off state. Now increase the applied voltage, that is forward bias voltage. The reverse bias junction J2 increase the depletion region at the junction J2 becomes thinner. A critical voltage called breakover voltage. It is denoted by VBO. J2, that junction J2 can no longer block the current. So next is breakdown and triggering. Junction J2 undergo breakdown, a sudden increase in current occur. This is turn on point of PNP diode. Next is regenerative action. Using the two transistor analogy, one PNP, another is NPN transistor, that is internally connected, which is already explained in that previous slide. The current of one transistor amplified the other transistor. This creates a positive feedback leading. So, so, so let us now understand the IV curve of the PNP diode. So, a PNP diode is also known as Shockley. So, two operating region in that curve. This diode is operate two main conditions: non-conducting state, that is off state, and conducting state, that is on state. We can see in that picture. In x-axis denotes forward bias voltage, and y-axis in this IV curve denoted anode current. So now conducting region, that is forward blocking region, when a small forward voltage is applied, the current is very small, called the leakage current. It is reflected in figure. So that device is remain off state. This is because the middle junction J2 is still in reverse bias. This region continues until the applied voltage reaches the breakover voltage. Means that apply voltage increases up to breakover voltage, that now the device start flowing the currents. That breakover voltage, the device suddenly switch on and current increases rapidly. This transition is very sharp due to the regenerative feedback. Now conducting region, that is on state, reflected in that picture, that is on state, the diode conducts heavily. Voltage across the diode drop to a lower voltage, that is Vk. This device we have like a closed switch, and latching holding currents once on, the device remain on even if voltage is reduced. It turns off only when current is falls below, that is holding current. The holding current required to initially turn on is called latching current. Then reverse bias region. Only a reverse bias condition in that picture, only a small current flow initially at reverse voltage. Above the reverse breakover voltage, the current is suddenly decreases, which is reflected in that IV curve picture. So next is another diode, that is TRIAC, is three-terminal semiconductor device used to control the AC power. means that type of diode is used in power electronics circuit. The name of TRIAC is stand for triode for alternating current. Triode for alternating current. So basic definition, a TRIAC is similar to a SCR, silicon control rectifier, but unlike an SCR, it can conduct current in both directions. But this makes it ideal for AC application when current alternate direction. So terminals of the TRIAC. A TRIAC has three terminals, that is main terminal 1, terminal 2 and gate. The gate terminal used to trigger the diode device into the conduction. Means the working principle, when voltage is applied across the terminal 1 and terminal 2, the track remain off initially. When a gate plus is applied, the device is turned on and current start flowing. Since it is a bidirectional device, its conduct is positive half cycle. It is also conduct a negative half cycle. So next is what is the construction of TRIAC? The TRIAC is a bidirectional semiconductor device designed to control the current in both directions. Its construction is more complex than a simpler SCR, silicon control rectifier. So basic structure of TRIAC. The TRIAC is formed by multiple P-type and N-type semiconductor material. It can be visualized as a 5-layer. The device with an arrangement that allow the conduction in both directions. So the TRIAC can be understood. The two SC are connected in anti-parallel with a common gate terminals. One SCR means silicon control rectifier conduct during the positive half cycle, and then other is conduct during the negative half cycle. The TRIAC has three terminals, that is terminal 1, terminal 2 and one other is gate terminal. The gate is connected internally in a such way that can trigger the conduction for both directions. So what is the internal layer arrangement? The internal structure consists of inter P-type and N-type region. These regions form multiple junctions that enable bidirectional conduction. The structure ensures the current flow from T2 to T1 and T1 to T2, means terminal 2 to terminal 1, terminal 1 to terminal 2. So gate structure, the gate terminal is connected near the terminal 1. It consists the trigger of the device in both polarities. A small gate current is sufficient to turn on the TRIAC. So their key design feature, the track construction is designed to provide bidirectional conduction, gate control switching, compact replacement of 2 SCR. So what is the IV characteristics of the track? So which explain its behave under different voltage conditions. For blocking state, initially when the track is not triggered, it's block current in both directions. Only a very small leakage current flow. This means the track we have like an open switch in both positive and negative cycle. Next is breakover condition. When voltage cross terminal 2 and terminal 1 is increases, once it is exceed the breakover voltage, then the track start conducting. This can happen in both positive and negative direction. However, in a practical circuit, we don't really on breakover voltage. Instead, we use the gate terminal to trigger the conduction at lower voltage. So role of the gate control, the gate voltage control when the track turns on by applying a small gate plus voltage, we can trigger conduction at desired point in the AC cycle. This is why track is widely used in AC power control amplification circuit. Now on state characteristics, once track is turned on, it allows a larger current to flow through it. The voltage drop across it become a very small, it behave like a closed switch. So at a moment of switching, one is high iris currents and may flow that this is sudden current and damage the device. So symmetrical operation, the IV characteristics are symmetrical in both quadrants. This means the track can conduct in positive half cycle and negative half cycle. That's why it is an idea for a AC circuits. So advantage of and disadvantage of track. Track needs single fuse for protection. It can trigger either with the positive and negative voltage. It has safe breakdown in their direction. It turns off when the voltage is zero. And disadvantage, track is not suitable for DC application since it is triggered at either direction. Trigger circuit should be considered carefully. So application of track is used for high power lamp switching, use a control AC power, use in light dimmer, used to control the speed of electric fan and small motors. Next, another type of special diode, that is DIAC. DIAC stands for diode for alternating current. It is two-terminal bidirectional semiconductor device used mainly for triggering of track. So a DIAC is a symmetrical device that allow to current flow in both directional only after a certain voltage is reached. It's behave like a switch that turn on at a specific voltage is called breakover voltage. So now construction of the diac. The diac typically has 3-layer or 5-layer semiconductor structure. It does not have gate terminal unlike that TRIAC. It has only two terminal, that is terminal 1 and 2. It is denoted anode 1 and anode 2. So working principle of TRIAC: when uh, a bidirectional switching, so that structure using semiconductor layer of p-type and n-type terminals typically has 3-layer PNP and NPN of or 5-layer structure, that is symmetrical design. The most important feature of diode construction is symmetry. Both sides of the device are identical in structure and doping. This symmetric allows the diode conduct equally in both directions. The terminal has T1, T2. There is no gate terminal like the TRIAC or SCR. Junction formed depending upon the structure. Multiple PN junction are formed. This junction control the breakover behavior of device. The central junction play the key role in the blocking of current until breakover voltage is reached. So the diode can be visualized as a two diode connected in anti-parallel configuration. This explains the bidirectional application. So next is characteristics of diac. During the positive half cycle, T1 is positive with respective to the T2, where T2 is positive with respect to the T1 is negative half cycle. When the voltage is below the breakover voltage, only a small leakage current flow through the device. It stays in off state. So advantage and disadvantage of diac. The diac smooth control of power and current is achieved using diac. The device can be turned on or off by decreasing the voltage level, reliable for the low power applications. Disadvantage: the main disadvantage of diode is that need minimum 30 volt to conduct. Next is application. Diode for alternating current is mainly used for a lamp dimmer circuit. It is also used for heat control circuit, and it is used for triggering the device for track. Speed of universal motor can be controlled using them. Next is different between TRIAC and DIAC. Triode for alternating current, that is DIAC for diode for alternating current. It is a terminals, main is T1, T2 and gate terminal. DIAC is a two terminal T1 and T2. It is a control bidirectional switch. It is uncontrolled bidirectional switch. It is triggered by applying either positive and negative voltage, but it is a trigger usually apply 30 volts. It has separate control input to use for triggering the TRIAC, but it does not have control unit to trigger the TRIAC.